All right, hello everyone. We are back for another episode of GIS 101. This webinar series presents a non-technical overview of topics within GIS to benefit NSGIC members and others to learn more about key GIS topics and to share what they've learned with the people that they communicate with. So today we have Greg Bunce from the Utah Geospatial Research Center presenting on geocoding. Take it away. Resource Center, my apologies.
Yeah.
Take it away, Greg.
Yeah, no worries at all. Well, that is funny because we just changed our name, and I'm still struggling with getting Resource Center as well. I think I'm saying Reference Center, but so no worries there. But well, yeah, thanks Emily for the introduction. And I got to say right out of the gate, I'm really excited to do this presentation today because geocoding, I think is one of the most foundational pieces of GIS, and not only for GIS, really for almost everything we do these days. It's hard to find an industry that isn't doing something with GIS. So without further ado, let's jump in on what is geocoding exactly. And again, this is a high level presentation, so I'll try to cover some of the high level basics here, but really geocoding, I think the easiest way that you could describe it is it's almost like a translator between us humans and the way we view the world and we move through the world and the way machines want to view the world. And kind of, what I mean by that is we like addresses. We like to refer to our home address with a street number and with a street name and street type, and that's comfortable to us. But a machine really on the other side, that doesn't make as much sense. It wants to see a coordinate pair, a lat long oftentimes. And the geocoder is kind of what gets us going between the two. And we'll see how that evolves here in this presentation and how that works. So the typical, I think one that we can all quickly relate to is just a typical street address. We like to say 506 Columbia Street in Hood River, but in reality, a machine and a GIS, it's going to want a lat long coordinate. And to that's going to translate to the coordinates that you're seeing on the right. Another way that we can communicate, and this is growing in popularity, these are these open location codes. So you may have seen the plus codes, the Google plus codes, or the what three words. But again, they look cryptic in nature, and they look a little scary in nature. But again, these also need to be geocoded back to a lat long or just a coordinate somewhere on the Earth. The convenience of these is that they're a little easier for humans to manage and to, it's easier probably to say broad and radical finest, which is those particular three words that what three words is decided to use for that coordinate. So it's a little more comfortable for us, but still, again, it does need to be geocoded back to a lat long. And we'll take a closer look on the next slide here on how these work and why we would even want to use these. So I was thinking about an example for this. Most folks in GIS or I've been to the UC, the user conference, the Esri user conference, and they've been to the San Diego Convention Center and realize maybe the first time you arrive that it is ridiculously huge. It's hard to get around the building. It's hard to know where you're going in the building. So I thought this would kind of be a good use case. So if you go to the Convention Center's website, you're going to see that the address is 111 West Harbor Drive, and that's great. That's going to get you there. However, if you want to be more specific about where you are in the building, or maybe where a dock delivery comes in, where you need a delivery coming in, that main address there is not going to cut it. So this is where these plus codes come in and these what three words, and really essentially they're kind of the same thing. They're both they've broken up the world in 3-meter grids, and anywhere you are on the planet, you can get a location there. You can geocode that location and you can get directions to that location. So the example here I'm showing on the left of the screen is there's that grand staircase out back, and say you wanted to meet somebody there. That really the easiest way is to grab that 3-meter grid, and you can see it highlighted in red there on the stairs, and send that to somebody. The plus codes are hierarchical, so they basically, there's a hierarchy to them, so they kind of make sense in a system. The what three codes, that's the same one for that location, else avoid local, which seems like a little bit of a scary one there, but those also, the what three words are just random 3 words, but putting them in a geocoder, you're going to get that location and you can get somebody routed to there. So that's kind of the strong point there. And those can be used, sometimes you'll see them in they're starting to get thought of for elections and stuff. And we'll talk about that in a little bit on tribal land where it's hard, where folks don't have addresses. And last thing probably worth mentioning here is a large majority of the earth and people out there living who do not have standardized addressing. So these are key to those individuals. So who geocodes? The shortest answer here is literally we all geocode. My mom geocodes, my dad geocodes, my kids geocode. I don't think they realize that they're geocoding, but what we're doing on the back end is literally geocoding, and it's kind of a nice way to often describe GIS and geocoding, is to go to something like the Google Maps. I think we've all used Google Maps. And if you've ever put in an address in Google Maps and wanted to route somewhere, you put in a standardized human address, street address, and what's happened on the back end is it's converted it over to a lat long. Also, so that would be called like forward geocoding. The other possibility is something called a reverse geocoding. And a lot of our location services on our phone constantly kind of seeing where we are on the grid. We'll see here on the next slide how reverse geocoding works there. So it's worth taking a minute here to discuss what reverse geocoding is, because it's very commonly used as well. I don't think we realize we're using it as much, but it's happening using a standardized geocoder. So if you've ever opened up Lyft or Uber app, you've basically done a reverse geocode. So these companies like to log your address, your home address, and various other addresses where you're heading to. But when you open up the app, you're getting that classic "you are here" sign, and it's going to locate you as a lat long coordinate. But what's happening then is it's searching for your nearest address and says, is this where you are? This is your house number. Is this where you want to be picked up? So that's reverse geocoding. It's used in 911 at the dispatchers as well, at the dispatch centers as well. And I got an example of that coming up, so I won't hit on it at this moment. So really, there's an abundance of geocoders out there. And again, this, mentioned here, but this list is by no means inclusive. This is a starter list of some of the more common ones, but there are many available geocoders out there that someone who's interested in this, that wants to get involved. I mean, you could visit any of these among many other and get set up with using a geocoder. Some of these are free, some of these cost, but they're ready to go. They're plug and play. But there's also, you could build your own geocoder. And if you're fortunate enough to have the data and the ability to do this, I think this is a great way to make use of the data that you have already and construct your own. So some of the benefits of using your own one is you do have full control up to correct the data and improve the data. So obviously, when the geocoding is happening, you're looking at underlying data, reference data, address points, road center lines, etc. So the geocoder really is as good as the data that you have. And if you feel like you have good data, I think that's a great way to either improve it and get updates and corrections in your data. Also, it helps enhance IT systems that might be existing. I work for a state organization, and our geocoders help enhance the systems around us. Sure, they could go to a geocoder and purchase a geocoder, but the ability to use ours at free of cost is huge for them. It promotes collaboration. Again, we work with stewards of the data, and as we improve the data, we're constantly working with them to get better. And it's a two-way relationship, right? They're giving us data, but also they're getting geocoding services, so they have stake in making sure the data is of quality. A wider use of audience, yeah. So this one, not everybody wants to use our lines and our set road center lines, our lines and our points, our address points. It might not be of value to everyone, but a geocoder might be of value to them. Adds accountability to the data. Again, the data is being used and it's geocoded. You're going to find situations where it might not be accurate and you have the option to correct it. Adds value to your data. I think we discussed that. This one, it opens the door to the value of GIS for a lot of folks. A lot of folks come into our office wanting the geocoder, and then it gives us an opportunity to have further discussions on the importance of GIS and data visualizations. And oftentimes this evolves into other services we're providing, and it's just an education opportunity. And then it does have the potential to generate revenue, much like a lot of these other companies that are charging for geocoders. They get heavily used, and if you're an agency who needs to generate money, this is a possibility. So say you were going to build your own geocoder. I kind of came up with this little cyclical diagram here, and we'll run through each of these to see kind of the evolution of a geocoder. And the first off is quality data. That's well, I guess first off is the idea, the light bulb moment. This is a good idea because there's many reasons and great uses. But then the next step I would say is the data that goes in, the reference data. And by this, I think, you're looking for authoritative data. That's key. If you're going to build a system, you want to make sure the data is authoritative. And then address points are the most typical data, reference data things, I think, that or the most accurate that you could put into the system. Road center lines would be the next. And then I've also used assessor parcels. You can get the center of a parcel, and parcels often have an address component to them. And they're kind of a fallback, but I think they can be used there in a system that's checking multiple sources. If it can't find address points, road center lines, I think parcels are a good source to check as well. So the next would be maintaining and updating this data. Yeah, it's not good enough just to get it in the house. You want to make sure that there's an update cycle to the data, that the data is not stale. You have a relationship with the steward to make sure that it's getting updated and that it has maintenance on it for corrections. So this slide here, this is not, this is not a fit all for every agency or state, but this is a typical one, and this is how Utah operates when we aggregate and update our data. So we pick up data from the bottom up, and I think it's best to have data maintained and created as close to the data source as possible. So tribal lands often can roll up their data to local municipalities or agencies and PSAPs. And those agencies can roll their data up to the counties. The counties then have the opportunity to add data so the local municipalities might be cities and towns, but the counties also have additional data that's in unincorporated areas. They have a chance then to put their data into the data set and then roll it up again to the states. The states can pick it up from the counties. And then I think the biggest piece here is it can go up to the next level, and I think it should. It should go up to the national level. And I know NSGIC has done, put a lot of effort into supporting a lot of these initiatives, such as the NSDI, the National Spatial Data Infrastructure, which is a great program and a great data source. Also, the Department of Transportation's address database, the national address database. NSGIC has played a really big role in those two, and I think it's critical that we as states and agencies below that continue to get our data up at the highest level so it can be used across broader areas. I think I'm going the wrong way. Here we go. We're back. Understanding the data. This is a big one. There's a couple slides here that I won't get into the weeds too much here, but I think there's some important things before you build a geocoder to understand about the data. And we'll focus here on road center lines and address points and the differences between the two. So road center lines, some of the things that you'll want to pay attention to is the direction of a line segment. So the image on the right here is the center of that image, is the center of that addressing grid. So everything radiating out from it will go higher in numbers in either direction. And this is specifically, we're thinking of road center lines here. So as you look at the data, you want to make sure that these road center lines, that the direction of the line is radiating out from the center. So as you build the geocoder, a road address is heading on this eastern road segment here, that the addresses are increasing, the range is increasing. And then additional things, you'll have attributes on both side of the line. So the road center line will have attributes on the right and attributes on the left. Oftentimes, you'll have on one side, it'll be odds and one side is evens. You'll kind of want to pay attention to looking at the data to make sure that's consistent throughout. If it's not, there are ways to override that, something called parity. So in Utah, we have odds on the left and evens on the right as you're traveling along the direction of the line. If that's not the case, we have the ability to inform the geocoder that the parity is off. Maybe there's both on that side, or maybe it's switched. But understanding that before you build a geocoder is key. Alias names, that's another thing you'll see in a lot of road centerline data sets. This example down here at the bottom is, I think, one of our craziest, but you can see it's got 1, 2, 3, it's got 4 alias names for this particular segment. Making sure that those are able to be found as someone inputs that at one of those addresses, one of those street names into a geocoder, making sure it's finding all of those possibilities. Address points are kind of a whole different idea here. You're not going to have the ranges going on, but you have much more precise locations on them. You're able to have, because of that, you're able to have sub-addressing. You're able to put a unit number or a suite specifically on that address point and move it exactly within the building where you want it. You don't have that ability in road center lines. For place names, you do have the ability to attach place names, and that's really critical for a lot of systems such as 911. Maybe it's valuable to know that you're not only at a particular address, maybe it's valuable to know that you're at the post office, because possibly a call coming in that needs to be coded, they'll just maybe they know the post office that they're at, but they don't know their home address. So address points will give you that ability, or the structure address, excuse me. Another heavy slide, but I think worth kind of going over some of this stuff, staying on the theme of understanding the data. So oftentimes there's domains in the data, and it's key to understand these. We have a city called St. George, and how many ways can you get that into the database? But a domain will enforce one way, a standardized way, and then you could build the geocoders around it. And you could see St. George here. It could get a little confusing with ST. Is that street? Depending on how the addressing goes. So understanding that before you build it is key. This is one of my favorites, understanding local vernacular. I don't know why I've kind of enjoyed local vernacular on how to refer to places. And Utah seems to be, of all the places I've lived, I feel like there's more local vernacular here than anywhere else, which is maybe drives some of my excitement for this. But there are ways to take that local knowledge and pull it into the database, into the data set that's going to be used. And I think it's worth thinking about. And the idea here is that, the idea on this optimize the data in a derived data set, the whole idea is maybe you have one single data set for, let's say, roads again. But maybe when you want to build the geocoder, maybe out of that one universal data set, you can pull out a derived data set and add things. You can augment it by adding some local vernacular into a derived data set for the geocoder. And some of the things you can do here, and again, these are specific to Utah, but I think they're worth mentioning. So we have roads here that end in 00, so 4500 south, but locally they're known as 45th, 33rd, 39th. You could bring that into the database because a caller might say they're on 45th. Or they might input it in, using a geocoder. They might say they live on 45th. 900 east, 900 south is an area that's just known as 9 and 9. Acknowledging that in the data is key. Another one that we do is emitting predirections. So in a database, most addresses will have predirections, but oftentimes we omit them because there's not another. So for us, it's Wasatch Drive, and there's many of these. Technically in the database, it's East Wasatch Drive. And if you build the geocoder with that and you try to code something, a valid address, but you don't put in the East because we just locally don't say East, we just say Wasatch Drive, you're not going to get 100 score. You're not going to get 100% match on that because you did lack the E. So you can know where and when to omit that and put in additional records. So when somebody puts in Wasatch Drive, you do get 100% match. And then omitting segments without address ranges at all. That lightens up the database a bit, adds less confusion, and you would never geocode off of that anyway. So again, just optimizing things. Enhancing the input. So this one's kind of focusing on, now you've got the data ready to go in a geocoder. There's things that you can do on the front end as a user as a user's typing in something to geocode. There are certain ways that you can enhance that and some checks before you pass it to the geocoder to ensure that the user actually is getting a good quality experience. And they may have made just a minor mistake. So some of the things that are possible to do is, again, using the example here in Utah, we have these coordinate streets. They're kind of really funny to look at first. They almost seem like they're not correct addressing. But on the first one, they're 1300 east, 1840 south. That's the standardized way. Somebody might switch them by accident. On the front end, we know that, and we could switch them. We also know that our numeric streets have 2 directionals. And if someone tries to put something in without it, we can give a warning there because we know that's expected. We can also correct common misspellings in a geocoder. So I think that's key to think of too. If you're building a geocoder and there's things that are going to be commonly happen, you could correct that on the front end. For us, it's Tooele and Uinta. They come in, misspelled constantly. So then building the geocoder. And again, I'm using this term geocoder broadly. I think, it's also known as a locator. I think you can use those interchangeably, but I'm going to stay with geocoder for today. But so building it, things to think about when building it. So for road center lines, again, you're going to have a direction of the line, and you're going to have addressing ranges on the left side and the right side. And as you build a geocoder, it's going to ask you things such as, well, when you go along this line and you find an address, how far off of the address do you want to go to the right or the left to place a point to say where that location is? Now, this isn't true with address points, but this is true with road center lines. And something to think about here is it helps to know the polygon data that you have that things are going to be geocoded on. So the example here in the image on the right is a road here, McClelland Street. And you can see the black line there going up and down. That's the actual street. And then on the right side of the street is the city of Mill Creek. And on the left, in the more purple zone, is Salt Lake City. So if you were geocoding this 3158 McClelland Street solely off of a street geocoder, you would want to be aware that if you set your geocoder offset to anything less than 30 feet, then it would tell the user that they were actually in Mill Creek. So understanding that, and a typical 30 feet is a typical offset. So understanding that, well, my geocoders I might want to set them to 50 feet offsets to make sure to capture any of these nuances. Other things to think about is the extent of the geocoder that you're building. And what's the native coordinate system? When I worked down in Maricopa County, we worked with state plane coordinates. It was a county system, and that's the coordinates we stored on the back end. It didn't make sense to store things in lat long. Here we store things in UTM because the extent of our data is at the state level. If you're looking at national data sets, you're probably looking at lat long, but understanding the native data as coordinate system is very useful to how you're going to build the geocoder. Composite geocoders, these are key. I think if you're able to build one, if you have address points and road center lines, you're able to build an address point geocoder and a road center lines geocoder, and then you're able to combine them into one geocoder called a composite geocoder. And the other really key feature here is that you're able to prioritize them and say first hit address points, because I know they're definitive and I know that they have exact locations and I have control of them. If you can't find an address point, fall back to a road center line. Thinking about things also such as, what is the best match score that you want the user to get? If somebody codes something and it comes in and it scores in the geocoder at 55% accuracy, or is that something you want to pass on to the user, or do you want to bump it a little higher? Hardware and servers. This is becoming more and more of a conversation, but do you want to put this in the cloud or do you want to keep it on premise? Definitely something to think about. The cloud is scalable, but on premise gives you, has its advantages of being in-house. Making it useful. So thinking about, again, the end user of the geocoder, there's many. So once you build it, now you have to make it useful for the user. And there might be a variety of ways in doing that. You might want to make an API that folks can just hit directly through backend code. You might want a desktop version of it where they can use in their GIS desktop software, or a plugin for other applications. Spreadsheets are handy. You can make geocode plugins for spreadsheets. So folks can just geocode right out of a spreadsheet. But things to think about. And then on to now, let's use the geocoder. We put all this work into it. How can they be used? So there's, like I said at the beginning, there's ample opportunities to use geocoding systems. But I think these are a few to discuss here today, and we'll talk about just 2 of these specifically. But tax commissions like to use them to locate voters for online commerce, locating where things are purchased and what tax code they're in. Rideshare apps, again, is using the reverse geocoding. 911, huge user of geocodes. And then elections. NSGIC has a program, the Geo-enabled elections, which is a fantastic program that's getting elections GIS ready and using a GIS. And geocoders is such a critical piece to geo-enabling an election. And we'll take a look at that first here. But really, when geo-enable an election, or bringing GIS into an election, it's so key to be able to view a voter, visualize a boundary, and ensure the accuracy that they are in the district and boundary that you expect them to be in. And there's also transparency in this. I can see what's going to happen, because this is literally how the ballot is going to be created. So there's definitely there's something to be said about knowing that voter, I can confirm, is exactly in that boundary and will get that ballot. So let's talk about, again, let's keep on the election theme and talk about using a geocoder and how you might want to use a geocoder, and think about the difference between road center lines and address points. So in this scenario here, let's see, we got the red line down the middle is a shared line. So it's the municipal boundary again, and we actually have Mill Creek again and Salt Lake City going on. But it's also a voting precinct here in the state. And you can see that it's offset. It's coming in 33 feet again, or 30 feet. I think it's 33 feet coming off the road center line. But it's critical to know what geocoder you're using in this scenario. So let's zoom in a little closer. And so back to this, 905, we're looking at the 905, 907 on Gregson Ave. So getting a little closer, knowing the geocoder helps here. If we're coming in from an address point, it's geocoding off an address point where we are certain that 905 is in Mill Creek, and they're going to get a Mill Creek ballot. If it's coming in from a road center line, we are also certain, actually, that it's going to come in the Mill Creek. A geocode off a road center line is going to go proportional along the road segment, and depending on the beginning of the road segment, and I know Gregson Ave starts at 900, so it's going to proportionally go into 905 where it thinks it is, and then it's going to offset, it's 50 feet, and say, which is, it's probably going to get pretty close to where that address point is. However, something to be aware of is that because we have this 33-foot offset, say someone tried to come in and register at 903 East Gregson Ave, and we were solely relying on a road center lines geocoder, that blue, so I use some reverse geocoding functionality right there, so I can move my mouse around the map, and it'll tell me where it would geocode that. So at that point where you're seeing that blue pin, that would technically geocode 903 East Gregson Ave. If I was using a street geocoder, would actually put you in Salt Lake City. There are ways to correct this. Obviously 903, we probably have an address point for it. But the point being is that you potentially could get different results depending on whether you're using road center lines or address points, and knowing your offsets, knowing the addressing system really is key, and knowing the data is key to how you code these things. There are definitely things, if you were solely using a road center line geocoder here, there are definitely ways to correct this and ensure that you get the right district for 903. Offset, we talked about offset again. I don't want to belabor this too much, but I think this is just a quick example. Again, happens to be just in the same area. This address here pointed out 3059 is coming in from the north-south road, 900 south. And we know that there's about 30 feet there off the road center line. So we'd know, again, using a geocoder, we would be comfortable knowing if we had a 50-foot offset that our road center lines would get us in there as well. But knowing the data and knowing the geocoder gives me comfort to know that that one, no matter what geocoder it used, we'd be fine. Moving on to NextGen 911 and kind of reverse geocoding example here is, so this is an area that's very popular for hiking. And you're up there, you're heading up to this lake, and you know you're in Albion Basin. And say you've got to call 911 and your call gets transferred to the dispatch center and they say, where are you located? For me, I'm in Albion Basin. I really don't know much more than that. But this is where the power of reverse geocoding comes into play, where we now can go in the opposite direction and when they can give more context to the actual dispatcher. So with some simple reverse geocoding, suddenly we've gone from somewhere in Albion Basin to now when you add the reference data, you have so much more, it adds so much more richness to the area. Now we know we're at, 11030 Secret Road up in Alta. Now we've got a place that we can route something to and gets us in closer. So again, hugely powerful in response to 911. So that's dispatch side of 911. I think it's worth just mentioning in a next-gen 911 world, oftentimes we're talking about call routing, and this also, GIS is the backbone to call routing as well. And the difference being on the dispatch side, you're sending out folks to respond. On the call routing side, GIS is used in this way. So if I have a landline here at my house, I pick up the phone, I call 911. That landline is tied to a civic address somewhere in the city. That's instantly geocoded to that location. And then it also, before it even gets routed to the dispatch center, geocoding happens to say that, hey, you are in Clearfield or you are in Hill, and it will route the call to that specific dispatch center. This is where location is super key to know, where you're located. Again, much like elections, location is hugely key, and the accuracy of these boundaries is key. But then geocoding comes in and closes the gap. So I thought it was worth just to kind of show that, that's not the end of the story. It's cyclical. It comes back around. And what I mean by that is now that you've got the geocoders in place, now this is such a great opportunity to start improving the data that you have. In Utah, we batch geocode things every once in a while. So we got a hold of the we have the voter address, but we got a hold of the driver's license database and all the addresses on there. And we know that those are pretty solid, valid addresses. And for fun, we just push the whole batch of those addresses against our geocoder and, see what falls out. And the things that fall out or don't geocode are probably suspect issues in the data, areas that we can correct the data and make the data better. We monitor match scores as well. I think that's another thing that's key that you can do is say, folks are trying to geocode certain things over and over again, and you can see that on the back end, and the match score is low. Well, maybe it's time to look at that and say, maybe this is something missing in the data. Fishbone analysis is another thing that happens. We haven't run this, but it's pretty common to do. It's a great way of making sure that your address points and your road center lines are in sync and that things are going smooth. So fishbone meaning, you can see on the image here to the right, if the address points where they find themselves fitting on the road center line in that certain range, if everything's going well, it's going to look kind of like a fishbone. If you start seeing where things are crossing over, or maybe the parity's off and maybe the line is crossing over the road, these are areas where you can start to look at and say, maybe we can better the data. There's potentially something going on here. This last bullet we kind of already discussed earlier, but again, it's so key for us as well, is that it encourages so much more communication with our data stewards. They want the data to be accurate. We want the data to be accurate, and we're all invested in this because these geocoders get heavy use. So in closing here, I think, geocoding, I hope this presentation kind of has brought light to the importance of geocoding and how it's not just a systems thing or GIS thing. It's us humans use it. So many systems use it, so many things on the back end. It powers so much of the world and everything that we're doing. But it's also such a universal thing. It's one way that we can all speak the same language. It's the quickest way I can talk to a non-GISer about GIS. And often, again, it's the gateway into discussing how much more powerful GIS is, because this is the quickest way in. It's comprehensible. And again, just the last notion here is just the idea of, that the geocoders are as good as the data that you put in. So making sure that you're using authoritative and accurate data to build them. So with that said, that is, so here's my contact if you want to reach out, and whatever point of the journey you're on there, I'm happy to chat with you on the next stages of where you're going with geocoding. So feel free to reach out in either of those areas. But I think this is an opportunity for some questions.
Yeah, thank you so much for that. Lots of really interesting information there. My question relates to generating money. So is there any money that or revenue that's generated from the statewide geocoder?
Yeah, good question. So there's definitely potential for it. Here in Utah, we have discussed the idea. So we're kind of an interesting spot. We're a state office that actually does need to generate some revenue. And that is one area we've explored. We haven't fully done that yet, but we get, there's months we'll get about 50 million geocodes on our geocoder. So it's definitely an area we've thought about. And if we did, we bring it into, we would possibly give, it would be for like high-end users, the ones that are using it the most, and we'd offer it as a service. We'd continue to keep it free, but we'd say if you want a designated instance to the geocoder, you could pay this fee and guarantee that you're the only one in the pipeline geocoding that. So definitely something we've thought about, but so far, no, fully open and free to use, and it would remain that way for most users.
Who would be those like super users?
Yeah, so the super users would be the tax commission uses our stuff a lot. They again, like with online commerce, and so much of it going online. So there's something called the streamlined sales tax we do here in Utah. Multiple other states do as well. But knowing where, when you make an online purchase, knowing where you are making that purchase, and then the associated tax code goes against that. So there's geocoding. They're a super user. I mean, there's public safety. There's the Department of Transportation. There's voting. But I think we'd have to have the conversation. Do they want a designated instance for faster use as an option? But those would be some super users.
Great, thank you.
I had a question, and thank you for that wonderful presentation. Can you talk about how Utah sources the reference data for the geocoder?
Yeah, so we are very much in that situation where we pick up from the counties, and one of the things is we have over the years we've built really good, strong relationships with all of the stewards, and that has been just hugely key. But we roll it up from the counties, and we expect the counties most likely to work with, agencies like the tribal lands and PSAPs, and then we work with all 29 here, and then we promote like a standardized schema for the counties to help roll it up. They don't have to contribute, they don't have to adopt the schema, but it helps when we roll it up, and then we bring it in-house and we standardize it, and we try to run a significant amount of validation checks to make sure that things are aligned correctly, and then we roll it up from there. And then we do create a derived data set from that. So that data set that we create for address points, road center lines, parcels, etc., those are wide use data sets, but then we do create derived data sets from that specifically for the geocoding, as mentioned.
Cool. I have a couple questions. Can you describe the basic configurations of the geocoders that you use in Utah?
Yeah, absolutely. So it is an Esri geocoder on the back end, and it sits on an ArcGIS server. And essentially, we through that derived data set, we optimize the data in very many ways in there to make sure that the data has the potential to be geocoded has been cleaned and optimized in as many ways as we can get it to be. And then we bring in the local, the local language in there as well, the vernacular. But then from there, it does go into an Esri geocoder and sits on an ArcGIS server, on a server that we have actually at the state office. And it's scalable. I mean, it can handle a decent amount of geocodes coming in. We've thought about moving it over to the cloud, and I think that will happen at one point for more scalability. But that's exactly where we're at for now. The other thing that I'll just add is that we do a lot on the front end. So when a user goes to geocode something against it, we do a lot of optimization there. Again, if trying to fix anything that's just the low-hanging fruit stuff. And that's all just done in code, like C# code, and then that passes on to the geocoder. And then the user will get back what was done. It'll say, this is what we found, this was the match score, but this is what this is what you gave, but this is what we passed in. So there's opportunity for them to verify and look at that as well.
Well, thank you. And
Yeah.
I think you touched on it a little bit, but are there some examples of how geocoding is being used in Utah?
Yeah, for sure. As you would expect, elections is huge. All the voter registration database gets fully geocoded against the geocoder. Anytime someone moves or registers, it's getting hit. That geocoder gets hit there. 911 is a huge, again, I think we mentioned that the call routing is all based on this data. The dispatch centers are using the geocoder. The state legislature, so we have an API, so if you want to use the geocoder, it's free, but you have to sign up for an API key. The nice thing with that is that we're able to see who's using it, and just one of the last checks on the biggest users is, Health, Department of Health, the legislature, the Board of Education, the Department of Transportation, Corrections, Public Safety. I mean, a lot of the players that you'd expect to see in there, but definitely relied upon heavily. And I think that's another point kind of to note, is that once you build this out there and once you put it out there, it will get use, and it's something to consider to continue to maintain and keep alive, because folks do expect, they expect it to be there. So yeah.
Yeah, thank you so much. I think that's all the questions we have for you. So thanks for a wonderful presentation.
Yeah, absolutely. Okay.
Yeah, thank you so much.
You bet.